Hey everybody, Lars here. Time for the second video for Unit 2, and this is a good one because after we go through this video, you're going to have something really important in your programming toolbox. You're going to be able to do loops, and you're going to see what we mean after we get going, although you may have already read the slides, you know what I'm talking about. After this video and this particular facet in programming, you're going to be able to do a lot of stuff, because if you think of what we have done in the first couple of units, you've got simple data under your belt, you've got if-then, you've got different data types. Now you understand strings, you understand lists, and now you'll have loops so you can have data and go through it. And we're going to do something a little bit along those lines. But I want to go through, again, I have that pull and push of I want to be short and I want to be concise, and I want to, I don't want to drone on and on and on, but I want to make sure it's worth your while. I want to make sure it's long enough and it goes over the proper stuff. So I already whipped up some code. Let me run it. It's not going to do anything because it's just a list, but it'll allow me to get a window set up so that we can have an area where we can code and go back and forth from the interactive window. Okay, as you can see, I have some code in front of me, and all I really did here was I created a list. You can see it's a simple 6-item list. We reviewed lists in the last video, so you should be cool on that. What I'm going to do is I'm going to create what's called a loop, and what a loop basically, or if you ever hear the term iteration, that's what it means. What a loop is basically going to do is we're going to create, I don't want to even confuse you with these terms, we're going to create a construct or a way that you can go to every single item in that list and do something. So what I'm going to do right now is I'm going to create something called a for loop, and I'm going to say for. You can see that idle makes it orange. I'm going to say for I. Now, I is just a variable name. I could put a lot of different things in there, and you're going to see in code a lot of people do. It's just when we teach programming for whatever reason and we start doing loops, we use I and we use J and we use K. I think it hails from mathematics, and I think I talk about it in the slides a little bit. But I'm going to say for I in, and then, unlike some other languages that you might have experience with, C or Java, you create this long construct where you take the variable and then you say don't let the variable get bigger than a certain number, and then increment it or decrement it or do whatever, blah, blah, blah. We don't do that in Python. This is one of the areas where you're going to see how Python treats things a little differently. Here, all we do is we go through the list, and all you are ever going to do when you iterate in Python is just give it a list. So now we're going to give it a colon, and now you see we're indented for, and now I is going to be the first item in that list. So I is going to be equal to 2. So what am I going to do? I'll do two things. I'll print I, okay? And let me do it all in the same line. I'll print I, and I'll also print I squared right next to it, okay? And then, just to show you that you can do multiple things in a loop, I'll create a 2-line code block. So we're going to print I, and then we're going to print the square of I, then we're going to print a little divider thing there, okay, 4 little asterisks, and then you're going to go back to the top of the loop because the code block is over, okay? I'll even make that very clear by putting print the end out here, okay? So that's back out to no indentation. This is indented for, all right? So print I squared, and then you have 4 things there. So I'm going to print the first item in the list 2. Then when that's done, I'm going to go back to the top, and I'm going to get the next item 4. I'm going to do it for 4. I'm going to do it for 6, all the way until I do it for 12. And then when 12 hits, it'll be the end of the list, and you'll be fine. Everything will be done, and you'll go on with the rest of your code. Let's run it and see what we get. All right, and as you can see, it grabbed the 2 and it squared it. It grabbed the 4 and it squared it. 6, 8, blah, blah, all the way down the line. And then after it did it for the last one, it was over, and we dropped down, and just at the end we printed the end. Okay? We call it a loop because if you think about it, for I in my list, print the command, then it goes back up again. Does the command, goes back up again. So you can see it kind of looks like a loop when you trace it like that. So that's why basically we call it loops. The technical computer science term is iteration. Okay, and very simply in Python, we just say for I or any variable. Here, you can call it Fred if you want. I'll just call it Fred, print Fred, square Fred, blah, blah, blah. Doesn't matter. As you can see, we get exactly the same results. okay? So don't think the I is something magical. It's just a variable name that we use there. As you can see, we just stuck all Fred in there, and everything worked the same. I'm not going to leave Fred in there because that's likely to confuse the hell out of you when you take a look at this code later on down the line. So we're going to leave that I sitting in there. But to make the point, it could be anything. It's just a variable name at the end of the day. For whatever mathematical reasons, we use I, J, and K. Okay? Now, I just created a list and we iterated over it. But if you're an old-fashioned programmer and you do things the old way, you're used to using a for loop and saying, I want to do a for loop from 1 to 10. Okay? How do I do this here? Do I have to create a list from 1 to 10 every time? That's going to get old and that's going to get tired. And how do I pull that off? I'm going to show you how to pull that off. First thing I'm going to do is I'm going to zotz out this code, but we're going to leave it there. And we're going to run a grand finale later, and you're going to have it. Python's answer to doing loops of a certain size, 10, 20, 100, going from 100 backwards, blah, 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 is to use something called the range function. Okay? And doing loops usually involves learning how to use the range function properly. I'm going to say right here for I in, and then I'm going to run range. I'm going to say range, and we're going to learn some secrets about range, but for now I'm going to say 0, 10, 1. And I'm going to say print I. Now, what do you think we're going to get when I run that particular piece of code? I got I for my variable name and then range. It's a function. It's really not, but we're going to talk about that later. So what I do here is I start at 0, okay? It's where I want to start, but you know what? This is an interval, okay? Just like when we dealt with slicing. So what is 10? 10 is the first thing we don't want. It's exclusive. It's an interval in Python. And then the last thing we do here is we tell Python, hey, every time you go through the loop, increase by 1. Okay? Well, we tell range. We don't tell Python. You're going to increase by 1. So I'm going to start at 0, and I'm going to go to 9, increasing by 1 every time. So I'm going to go 0, 1, 2, and I'll print 10 items because we start at 0, but it'll stop at 9. At least I hope. That's the way it works back in the old days, and we get 0 through 9. Now, let's say you wanted to do a typical list from 1 to 10, like most people do. Well, then, you can just do 1 to 11, implement by 1, or increment by 1. Whoop, and you see, 1 to 10. Okay? Now, I'm going to teach you a little secret. If you just say that, 11, it'll run because it will use 0 as the default for the beginning, and it will use 1 as the increment. So if I want 0 to 9, I can do that. Starts at 0. 10 is the first thing you don't want. It's still the second part of an interval. So 10 is going to be the first thing you don't want. You're going to go 0 through 9. Just tell yourself it's 10 items at the end of the day. But it's an interval, and you increment it by 1. Because if I wanted to, let's say I wanted to go from 1 to 100, and I'm going to increment by 5. I can do that too. 1, 6, 0. See, that's a bad way to do it. Let me do 0. 0 to 100, increment by 5. There's my 5. So 0, 5, 10, 15, 0. So you can see I get the multiples of 5. And I can basically do that with any number I want. There's the 3s, up to 99. There's people in the park, actually. That's Bucolic Park out there. I have the windows open because it's a nice night. It's like 60-something. So that's why you probably hear crickets. But now there's people blabbing in the park, wrecking my videos. All right, I digress. So we can see you have a default start of 0, and you have a default increment of 1. So when I say the range is 10, I go up to 9. But let's say I wanted a countdown. Okay? Well, I can start at 10, and I can go to 0, which would be the first thing I don't want, and I can say -1. And what that's going to do is go down. So it'll start at 10. 0 is the first thing I don't want, so it'll end at 1, and -1 will make it go backwards. So I can do that, and I can get a countdown. 10, 9, 8, 7, just like that. So I could go backwards too. Okay? And there's no, there's no limit. You can do 10 to, now we'll keep it 0, and you can say go down by -10. And then you just get the 10s in a countdown, okay? So facility with range is important if you want to go through and do loops. Like we did this list up here, I could do that same list with range. If I want to start with 2, and I want to go to 13, and I'm going to increment by 2, okay? And then I'm going to print I, and I'm going to print I squared, okay? No, I hit the 8 on that. That's why that didn't work. So if I do this, you can see I get the same results that I did up here, except I didn't do the second print line. If I did the second print line, it would be the same. All right, but you can see I'm getting the same results as far as the math is concerned. All right, because what did I do? I started at 2, and I went to 13 because 13 is past 12, and I incremented by 2. Boom, 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 boom. And that's what it did. So facility with range is your important thing to worry about when you want to do like definite loops. Like I want to do something 10 times. Well, if you know you want to do something 10 times, then all you have to do is throw a 10 in there. You're going to get 0 through 9, and there you go. You can do things like that, all right? So now it's pretty snazzy, because now what we have, 1, 2, 3, is we've got simple data, we've got if-then, we've got lists, we've got all kinds of things. We can now start doing something with our code, doing some analysis. What I'm going to do right now is I'm going to do a quick little homework thing, little data analysis. Let's say I want to find out how many of the squares from 1 to 300 are greater than 50,000, okay? Just something like that off the top of your head. So the first thing I want to do is I'm going to jump into a loop. I'm going to say for I in range, and let's start at 1 and go to 301, because 300 is the first thing I don't want, and then I'm going to say the increment is 1, and then I'm just going to print I. So when I do that, and it takes a while to print, although it would run faster if you didn't have to print it, it goes all the way up to 300. So that's pretty snazzy, okay? But I don't want 300. I want the square, so I can do that. Uh-oh, didn't want to do that. Multiply everything by 22. So if I want the square, I could do that, and then when I rerun it, I get the squares. Now I look down here at these numbers and I can see that they're greater than 50,000, so there's going to be a decent amount greater than 50,000. But I'm just printing them, right? I want to use them. I want to manipulate them and see if they're greater and do things like that. Well, I could do that by putting them all in a list. So basically what I'm going to do here, and this is a more Pythonic way about doing it, is I'm going to create a list called square list, and I'm going to make it blank. And then down here, I'm going to say square list dot append I squared. Okay? So as I go through the loop, instead of printing the number, I'm going to put it in this list. So now when I run things, nothing happens. And you're like, uh-oh, did something go wrong? No, nothing went wrong. It's sitting there in my list. Watch. Print square list. So now when I print my list, it comes up in a list. You see the bracket there? You see the bracket there? Everything comes up in a list. And you might be saying, yeah, what's the big deal? You printed it before, and now you just have it in a list. Now that I have it in a list, and this is important, now that it's in a list, I can iterate over it, and I can go through the data, okay? Because that's what we do at lists. We iterate through them. So now, for I in square list, we're in Fat City. What do we want to look for? We want to say if I is greater than 50,000, what do we want to do? Print I. Now, for now, we're going to print it, but later on, we're going to do something else. So now the list is shorter. I come up here and I started at 5176. So it's working, okay? Because 5176 doesn't appear until right there. So everything before didn't trigger the condition. See? If I is greater than 50,000, well, all those weren't, so they got skipped. Okay? So now I can do one of two things. I know what I'm going to do because I want to show you how to do it, but then we're going to do it another way after this. I printed them all out, okay? And you see the list right there. But that technically isn't the answer to the question I asked. The question I asked is how many of them are there? So I'm going to show you how to do something called a counter. What I'm going to do is I'm going to create a crummy little variable up here. I'm just going to call it C. I'm going to make it equal to 0. So I have it. So now if I is greater than 50,000, I'm not going to print I. First, I'm going to create what's called a counter. And you can see I said C is equal to C plus 1. In programming terms, that's called clicking the counter. Every time I go through the loop, I'm going to add 1 to that variable. So at the end of the process, that variable is going to represent how many times I've gone through the loop. Okay? So it acts as a counter to count up all of those items. All right? So now when I'm done, I'm going to want that to report out. So I'm going to print C when I'm finished. Okay? You'll notice I took it out of the loop. So it's out of the for loop for square list. For square list. Okay? Because I'm going to do it at the end of the process, so I don't want it to be part of that loop. So now when I run things, at the end it tells me 77. So that's how many of the squares from 1 to 300 are greater than 50,000, 77. Okay? So we've answered our question, but now we're going to do some more interesting stuff. I got the counter. What if I wanted to know the sum of all those numbers? I'm going to create a variable called A. And I'm going to come down here and I'm going to say A equals A plus. Now, my counter clicked 1 because I want to know how many times I'm going through the loop. But if I want to accumulate, and that's what the A stands for, if I want to accumulate the values, then what do I want to add to that particular thing? I want to add the number itself. So I'm going to put an I there, okay? And then I'm going to go through the loop, and when I go through the loop, it not only is it going to count, but it's also going to add up all the numbers. All right? So I'm going to have C and A. When I get to the end, I'm going to see there are 77 of them, and they are equal to 5,323,000 blah. Okay? So that's how, in a looping construct, we do something called a counter, and we do something called an accumulator. Now, there's another way to do it. I want to leave this kind of up there the way it is, and I'll build it back when we're done because I want you to have it that way. But there's another way we can accomplish that particular task. Let's take it back to the square list where it just prints the item when we're done, okay? I could also do something like this. I could also do a list called GT50. And then here, I'll say GT50.append I. So now I'm just going to create a list with all those things, right? And then I'm going to print GT50 just to make sure I'm getting the right stuff. All right, now I have a list of all of the squares that are greater. So how do I get the numbers that I had before? Watch. I just print len of GT50, because what is that? It tells you how many items are in the list. Well, that's what we want to know. It's going to be 77, because if there are 77 squares in there, that's how many are greater than 50,000. Now, I also want to accumulate them. So what can I do? I can use the built-in function fun. What? I can use the built-in function sum and say GT. I got to go back and watch this video to even know what I said there. I don't know what I said. GT50. Hope it wasn't a cuss word. Don't think it was. So now I'm going to have the length and the sum, and I'm going to print them out. And as you can see, I get 77 again, and I get 5,323,000 blah, 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 which was also 326, I think. Right? Yeah, or 626. Okay? So that's another way we can do it. To my mind, that's a little bit more Pythonic, but I do want you to know how to do counters and how to do accumulators the old-fashioned way. So I'm going to go put that back. I'm going to say C is equal to 0. A is also equal to 0. So those things exist so that when I write C equals C plus 1, this is going to get evaluated right to left, and Python's going to go, C, I don't know what that is if I don't have that there. Okay, so I want to make sure it's assigned. I'm going to have A is A plus I, and then I'm going to print, easy, I'm going to print I, and then out here, I'm going to print C comma A. So that when we run it, it's just going to list everything, and then it's going to give me my value. All right? So, simplistic? Absolutely. But this is the beginning of data analysis, right? You created a list from 1 to 300, you squared it, and then you went and looked. If I is greater than 50,000, you used criteria and you weeded things out, and you found out how many were greater than 50,000, 77. And then you even did a little extra and added them together. Okay? So this is what we're going to be getting to. This is the kind of stuff that we're going to be all about. All right? There are 3 things left that I want you to take a look at. And I'm not going to rush, but I'm going to go through them pretty quick. I'm going to say for I in range, and then I say I'll go 5. Okay? Then under here, I'm going to say for I in range 3, do this. Okay? So for the first one, I'm just going to print outer. Let's make that a string, huh? So I don't get kooky errors. And then here, I'm going to print inner. Okay, so now when I run this, I get the outer, then 3 inners. Outer, 3 inners. If you count how many outers there are, there's going to be 5, 0 through 4. Okay, outer, 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 outer. This is what's called a nested loop. You can do loops inside of loops. So the first time you're in the big one, you run the little one and do 3, 1, 2, 3. And then you come out again. Then you do the next big one, outer, and then 1, 2, 3. You do that, okay? Outer, inner, outer, inner. Again, you're looking at this and you're like, that looks like just a parlor trick. Who cares about that kind of output? When you're going to care is when you're going to use that construct to go through table data. Because if you think of the outer as a row and you think of the inner as a column, that's how you access table data, okay? So if you want to access everything in a table that's 10 by 10, you're going to do, you know, the outer one will be 10 and the inner one will be 10. So row 1, 1, 2, 3, 4, 5, that's 10. Blah. Row 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Row 3, 1, 2, like that. So that's why I always show it to people. Okay? It might be a quiz question. Hint, hint. Okay, enough said. Hopefully you saw this part. So I do want to show people that and show them how it works. You can have loops within loops. Okay? So, enough said. Remember, possible quiz question. All right, let me zots this out. Now, there's another thing I want you guys to see really quickly, is that life is not perfect. And there's going to be a lot of times where you're not going to know how long you want to make your loop. You're going to have to wait for a condition, or you're going to have to do something. Well, there's a way we can have a loop that's based on a condition, and that's called a while loop. And it sounds like it is. While something is true, do this. Okay? So basically what I usually do here is I'm just going to take a silly variable called C. I'm going to make it equivalent to the string y, just the character y. And then I'm going to create a loop. I'm going to say while, and as you can see, idle makes it orange because it's a keyword. Now, you don't need parens here, but you can use them. I'm going to say while C is equivalent to y, which it is, do this code block. And then in the code block, I'm going to print OK. And then in the second line, I'm going to say y equals input, enter a character. Did I use the same things? Look how I use the single, but I use the double when I type out prompts. I have C on the brain. So then, what's going to happen? C is equal to y. That's going to make my OCD go crazy. Then I say while C is equivalent to y, which it is. We just assigned it up there. Print OK, but then I say, hey, in the variable y, put the result of enter a character. So, when that's done, it'll go back to the top, and as long as C is still a y, it'll run again, it'll keep printing OK. The minute that variable becomes something that is not a Y. Look at that. I used a Y. I should be using a C. The minute C is something that is not a Y, then I'm going to break out. Watch. Okay, enter a character. Y. Y. So it's Y right now, so everything is fine, because when I'm in here, I enter the Y, so C is still equivalent to Y. So when I come up here and say while C equivalent to Y, well, that's still true, okay? Until I come down here and I give it a Z. When I give it a Z, it ends, all right? I can even drive that point home by saying print the end, all right? So now enter character. Y, 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 Y. It's like those old Enron commercials, okay? Give it a Z, the end, and we're done. Anything that's not a Y. So this is two different things. One, this is a indefinite loop, because you don't know how many times it's going to run. Up here it ran 7 times. Up here it ran 5 times. Not a big deal. Okay? It's also what's called an interactive loop. It takes something from the user while it's running, and that's going to change a variable, and you get to control when it ends and when it doesn't. And if you can do that, it's usually called an interactive loop as well. Okay? So you have a while loop. You can say to yourself, if you wanted to do a definite loop, like your for loop that goes to 10, you know it's going to go to 10 every time you run it. But if you wanted to do that with a while loop, you could. Just set C equal to 0, and then when you're in your loop, click a counter. Okay? And then the counter will go up, 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 and up, and then when it gets to 10, you'll meet your condition, and boom, you'll go out. All right? So, again, play around with for loops, play around with while loops too. I know there's a lot of examples in the Zell book, and there's some, stuff out there. Play around with this stuff. That's how we get better at programming. All right, there's one more thing I need to show you guys, and that's a kind of loop called a Sentinel Loop. I will create a list called another, just another list, and I will put numbers in that list. Well, actually, I want them to be numbers that I can add up quickly. You will see why in a moment. All right, that's not going to matter. All right, I've got a list, and it is another, and it has how many items in there? There's 6, 7, 8, 9, 10. 10 items. So if I want to print that list, I can say for I in another. How about using a colon? Print I. Okay, so that should just print the missing parentheses. Oh, print is a function, not a statement. Get Python 2.7 out of your brain. So now I just, as advertised, I go through the list and every item is printed out in the list. Okay, but what if I wanted to just count up or add up? Let's say we add them. I wanted to add up all of the items in the list before 999. Okay? What if I wanted to look for a particular item? In this case, it's called the Sentinel, because this is called the Sentinel Loop. Okay? How would I do that? How would I do something like that? Because I'm used to, when I do iterations and I do loops, I'm used to going through the whole loop. I don't stop in the middle or do anything like that. Is there a way to do that? Turns out there is. What I'm going to do for I in another is the first thing I'm going to do is look for the Sentinel. So if I say if I is equivalent to 999, which is the Sentinel, I'm going to want to do something. Before I do that, I'm going to create my else. Else, and what do I want to do? I want to A equals A plus I. We'll add them together. So if I'm going to do an accumulator, I want to have it up there so it exists, and I'll say A equals A plus I, whatever. And then when I come out, I'm going to print A, and it'll print out all the accumulated variables. But I'm not done here because I didn't do my if condition. So I come down here, I is 2. For I in another, I is 2. If I is equivalent to 99, it's not, so I do the else. It gets added to the accumulator. I go back to the top. It grabs the next variable, 4. So 4, is 4 equal to 999? No, it isn't, so it goes to else, whoop, and it gets added. So now it's 6, okay, because it got added to 2. And we go and we go and we go until we get to 999. And then when it sees 999, what does it do? There's a keyword that allows you to break out of a loop. and it is well named because it is called break. And as you can see, Python makes it orange. So now I can break out of that loop. Break will break you out of the for loop. It's not going to break you out of the if-else structure. Break is to break you out of loops. Okay? So what you're going to do is you're going to say for I and another, and you're going to look for the Sentinel. Why? Because you want to look for the Sentinel first because you don't want to add it to the accumulator. Okay? So you want to look for it first because if as you're going along, you're adding all these things, okay? You're putting them in there. And when you get to that, you don't want it added. You want that to be the Sentinel. You want to get out of Dodge. You don't want to add the Sentinel to your accumulation. So now, I never even ran this. Let's see if it works. So now, I'm going to break when I hit 999. So this accumulator should count up 2, 4, 6, which is what? 12, there's 20, there's 30, there's 42. So 42 is the answer to the question in the universe. So I should get an answer that's 42. All right? And I do. So it says 42. Now, that's the Sentinel. Okay? It ignores everything after it. But if I wanted to add something after that, like I wanted to add 58, okay? Well, then I'd get 100 because it's still before the Sentinel. All right? It's not like I counted how many spaces over. So that is a Sentinel loop. You have a way to break out of a loop in the middle of it if you can detect a particular value. Okay? So, what do we have here? Got a lot of stuff. This is a good video. Teaches you a lot of neat stuff. We reviewed regular old iteration, just going through a list. 1, 2, 3, 4, 5, blah, blah. Then we learned how to use range. Facility with range is an important thing with loops. Make sure you go over this. Make sure you understand. Try, try, try. Do the exercises in the back of the slides where I think I have a whole bunch of different loops up there. Okay? Then, for the first time, we did some actual data analysis. We filled a list with the numbers from 1 to 300, and then we squared them and put them in the square list. Then we looked at the square list, counted up how many are greater than 50,000. And we actually accumulated them too, and we printed it out. We took a look at nested loops. We took a look at indefinite loops with while, but we also kind of did an interactive loop at the same time. And then the last thing we did is we created a list and we put a Sentinel in it, and we detected that Sentinel and broke out of the loop just when we wanted to get the right numbers. Okay? I am going to save and run, and look at that. Enter character Y, Z, and then 42 at the end. Jackie Robinson. So that is the grand finale for the loop video. Not too shabby. As usual, you don't have to type in all this code. I'm going to save this code, and I'm going to put it up in Canvas, so you're going to have it to just take down and play with it. Change the variables. Run it a few times. Make sure you understand how everything works, and everything is going to be okay. All right? So this was the second video for Unit 2, which is, the slides are 2 weeks long, so this is the last, standard review video you're going to get for Unit 2, but it's Unit 2, so stand by. There's going to be another video coming down the pike that deals with the Project Euler assignment and putting together some code now that we have tools in our toolbox. We have if-then, we have simple data, we have loops, we have all of this great stuff. Now we can start using it to solve problems. So the first thing we're going to do is we're going to learn about Project Euler, and we're going to run out there and we're going to grab a problem and we're going to solve it using our Python. All right? Then I'm going to get out of here. You be good, and I'll see you very soon.